Now we are going to talk about the superposition of waves. So the idea is this. The word superposition, it means ending up in science. Okay, so assume, okay, if I have two waves, okay, coming to meet each other. Okay, I have a black wave and a red wave. Okay, yep, coming to meet each other. When they met, okay, what happens is they ends up. Okay, they ends up like this. Okay, their amplitude will be doubled. Okay, then after they met, they separate. Okay, so like this. Now, this is basically called superposition of waves. It's a fancy word for just ending up. Okay. Now, have a look at another scenario. Okay. Because sometimes we have a wave like this. We have a wave which goes down, okay, meet with wave which comes up. Okay, so I have a wave like this meets with a wave, sorry, okay, goes like this. And when they met, okay, the wave cancels out. Okay, we have this wave ending up with this wave, and I have a straight horizontal line. Okay, then afterwards, okay, I have the red wave like this, and I have a black wave goes like that. It's also called the superposition of waves. Okay. But yeah, however, the scientists, okay, they invented some more fancy words. Okay, they use the word, okay, constructive interference for this situation here. Okay. They say that the waves met constructively. Okay. Because there are two waves and they meet in phase. So, and remember, that's all the word you need to be able to recognize or be able to use. Okay. Constructive interference occurs when waves meet in phase. Okay. And when they meet in phase, we have a higher amplitude. We call that antinodal point. Okay. So we have wave meet constructively because of their in phase, and antinodal point occurs, or antinode occurs in the center. Okay. Now, similarly, similarly, in this case, we have destructive interference. Okay. And the wave meet out of phase. And we have nodal points occur. when they meet. Okay. So those are basically the fancy words you have to remember for this topic. If you can't remember them, write them down in your cheat sheet. Okay. Yep, I show you what does it mean with the simulation here. Okay. So imagine if I have something like this. Let's restart it. Okay. Now, when I give a pulse, the wave reflects. Okay. Now, if I give it a second pulse and the wave meets, okay, you can see that those if I okay, those two waves, okay, they meet out of phase. Okay. So when they met, there is an there's a nodal point. Means the particle in the center, okay, when the two waves meet, it doesn't move. So if you have a look, the particle in the center, it doesn't move much, okay, compared with the other particles. So this is what we call the nodal points. Okay. Okay. Similarly, if I have something like that, okay, I give a wave, the wave bounces back. Okay. So if I give another wave, you can say let's say this. We have two waves. Okay. They come in phase, and when they met, the particle in the center jumps up higher. That's constructive interference antinodal points. Yep. Okay. You see that? So I say when they come in phase, they jump higher. Okay. So in reality, sorry. Okay. Okay. In reality, I show you what it means. In reality, the idea is if I have two speakers, one on one side, the other one on the other side. Okay. If I give a wave like this, and then give wave like this, so if you standing in the middle point, you will hear nothing because sound behave like waves, and the wave just cancel out each other. Okay. It's same with light. Okay. So yeah, we're going to talk about this later. Okay. But the other thing I want to show you is this. Okay. So assume I have this, and I gave yep, I gave a wave. Okay, sorry, I think I made a mistake. Anyway, I restarted. Now, have a look what's happening if I gave a continuous wave and it bounces back. Yeah, this is weird, isn't it? Okay, so let's do. Sorry. Okay, let's change to this one. Yeah, it will be all right. Say if I give a wave like this, you see what's happening is wave going to an end, bounces back, meets the wave from the other side. Okay. So if you have a look, especially those points there, especially those points there, it doesn't move much. So what can I conclude is at those points, waves met out of phase. This occurs. destructive interference occurs, wave met out of phase, and we have nodal points. We have nodal points there. Again, if I have two speakers on the side, if you're standing on those points, you hear nothing. You hear nothing. We call them nodal points. However, if you look at the particle at here, the particle move up, vibrates up and down at a greater amplitude. Those are when wave means constructively. So constructive interference occur because wave meet in phase, and if you have two speakers, if you're standing here, you are going to hear more sound. You're going to hear higher volume of sound. Okay, so let me just yep. So you say yes, this is what's happened. Now again, an important thing is to memorize those languages. Because what's happening in the end of the exam, the examiner will ask you to explain. Okay. They will show you something like this and ask you why someone at this point hears no sound. You need to be able to tell them that it is because of wave means out of phase, destructive interference occur, so we have nodal points, and he stands on the nodal points, he hears nothing. So you need to basically mention all these three dot points when people ask you to explain it.